Good morning, everyone. I wanted to do a brief devlog update video on the state of my multi-threading C program. C is a language that is capable of operating at an incredibly low level, but is still powerful enough to support more highly abstracted and powerful tools like concurrency. Previous versions of the program utilized multi-threading, but not concurrency. The latest version of the program has been updated with concurrent thread operations to model an energy grid with one thread generating power and multiple others attempting to draw it at the same time. To this end, mutexes, thread conditional variables, and thread barriers have been implemented to prevent race conditions, improve stability, and improve performance. The declarations of which you can see here. You may note that we have a preprocessor macro named threadNum, which should be this guy here. This ultimately decides how many threads will be created and joined. In the section below, you can see the WinPower function, which utilizes a random number generator to produce power units within a range. These units are stored in a global battery bank variable, which other functions draw power from. Mutex locks are used to prevent race conditions that might result from other threads attempting to modify the battery bank value while another thread is already accessing to read or write it, which you can see here. In a similar vein, thread condition waits and broadcasts are used to ensure that threads performing the draw power function only do so when the battery bank variable has enough power units to successfully draw from. Finally, a thread barrier is established which forces other threads to wait for completion of all active threads before the program moves on to the final exit. The system calls used in this section are POSIX specific, which you can see here. This means that while not highly portable, they give a clear indication of which threads are active and which threads are pending. You may notice that thread creation is performed using a for loop. This is in accordance with drive principles and more importantly allows for a slightly more flexible approach to thread creation and joining. This loop includes a limited amount of error handling, both in the event of thread suppression, which is usually handled by the kernel, and in the event of thread joining failure, which is usually a runtime error. You can see these two in the call for p error here and p error here, one for creation and one for joining. Actually, one for joining down here and one for thread creation up there. In the last section, we reclaim all of the occupied memory. This is in order to prevent memory leaks. C and C++ are somewhat notorious for their lack of automatic memory management tools, such as Java's garbage collection or Rust memory ownership rules, so it's important that we destroy and free the memory utilized by our various thread tools and other dynamically allocated resources. Thank you for watching this short developer update log, and I hope to see you in the next.